Part 1: Introduction to Object-Oriented Programming. What is OOP? It's a way of writing computer programs where we group data and functions together into something called an object. These objects represent real-world things like a person, a car, or a bank account, and each object has attributes, characteristics, and methods, actions. Importance of OOP. OOP is important because it helps make programs easier to understand and organize. It also saves time since you can reuse code instead of writing it again. Now let's proceed to real-world analogy or example. Real-world analogy or example. Let's use car as an example to understand OOP better. A car object can have an attributes like color, brand, and speed, and methods like drive, stop, and honk. In programming, we can create many car objects from one class, just like making different cars in real life. They all come from the same blueprint but have unique features.
So sa programming, marami tayong approach na pwedeng gamitin. Pero in this part, magpo-focus lang tayo sa dalawang approach, which is ang procedural at OOP approach. So mag-umpisa tayo sa procedural. So yung approach na to is nakapokus sa function and procedure. So yung structure ng approach na to is step-by-step sequence. Kumbaga, gumagawa tayo ng listahan ng instruction na gusto natin ipagawa sa computer natin or sa code natin. And also, yung data and function nito is magkahiwalay. Kumbaga, nagkakaroon lang sila ng connection kapag ginagamit natin sila. Para mas malinaw, here's the sample code. Nakita natin sa code natin na gumamit tayo ng maraming function o method, which is mayroong specific task na ginagawa. Mapapansin natin na hiwa-hiwalay sila lahat na walang direct connection sa isa't isa. Kumbaga, nag-exist lang sila individually. Sa main method naman natin, dito natin makikita kung paano natin sila pinatakbo sunod-sunod. Kung saan yung bawat function ay tinatawag base sa order or instructions. Gaya nga nasabi ko kanina, para siyang listahan ng instruction na gusto natin ipasunod sa computer natin. So, ganyan gumagana ang procedural programming. So ngayon naman, mag-proceed tayo sa pangalawa nating approach, which is ang OOP approach. So yung approach na to is nag-organize ng code using an object. So yung object na to ay gumagamit ng class as a blueprint. So kinukuha ni object lahat ng data and function ng class natin. So para mas madali nating intindihin, here's the sample code for that. Sa sample code natin, gumawa pa tayo ng isang class which is magsisilbing blueprint ng object natin. So sa loob nito, makikita natin yung iba't ibang data and function na gumagawa ng specific task. So kapag gumawa tayo ng object, gamit yung class na yun, pwede na rin natin yung gamitin ng mga methods and data na nasa loob ng class na yun. So ganun gumagana ng object-oriented programming. So gumagawa tayo ng class at object para ma-organize at mapaikli ang code natin habang mas madali pa rin itong intindihin at i-manage. So, mag-proceed tayo sa advantage ng OOP. So, una na dyan is mas organize yung code natin. Pangalawa, may encapsulation para mas secure. Pangatlo, may reusability kaya hindi na natin kailangan ulit-ulitin ang code natin. Pang-apat, mas madali ang real-world modeling. Panglima, mas madaling i-maintain. At pang-anim, mas stable habang lumalaki ang project natin.
The first concept that we will tackle is object.
In object-oriented programming, an object is simply an instance of a class. A class is like the blueprint, and the object is the actual thing created from it.
Here's an example. I created a shoes class with attributes like type, brand, size, and color. It also has a method where that prints out the details of the shoes being worn. So how do we create an object? We create an object by using the class name, the new keyword, and the arguments. If the constructor needs information like a type or brand, you must give those values inside the parentheses. But if the constructor doesn't need anything, you can leave the parentheses empty. Here in the main class, I created an object A that represents one actual shoe. The wear method then displays wearing a size 37 red pump heels from Jimmy Choo. Our next concept will be encapsulation.
Encapsulation is about protecting the data of a class by making variables private and only allowing controlled access through methods like getters and setters. This way, we prevent direct changes that could cause errors or inconsistencies.
In this example, I created a class called Internet Data Load. It has private variables like provider, load, data balance, and number. Since they are private, we cannot access them directly. Instead, we use public getters and setters to safely view or update these values. In the main class, I created an object named byload2 with values TNT, sayaol, 6, and 932713224, and then called the method display details. At the bottom part, I updated the data balance from 6GB to 9GB using a setter method, set data balance. The details are then displayed with the updated balance. Our last concept will be inheritance.
Inheritance allows us to create a new class from an existing class. The child class inherits the properties and behaviors of the parent class, and it can also add its own unique features. This avoids repeating code and makes our program easier to manage.
In this example, the parent class is payment transaction. It has common details like amount and date. From it, I created two child classes, cash payment and online payment. Cash payment calculates the change based on how much cash is given. Online payment instead stores which method was used, like GCash. Both override the process payment method to display their own details. In the main class, the child objects are created and used to show the overwritten methods from the parent class. In the output, you'll see the cash payment shows the change while the online payment shows the method.